Hello everyone, welcome to Pratibha Tech. In this video, we will try solving the problem of the day question on Geek for Geeks for 4th February 2023. The problem statement says max sum without adjacent, which is based on arrays and DP, that is dynamic programming, and this question has been asked in many companies like Paytm, Amazon, Oyo, Walmart, Adobe, etc. etc. So let's open the problem statement. So let's go through the problem clearly first. So the problem statement says, given an array of size n containing positive numbers, find the maximum sum of subsequence such that no two numbers in the sequence should be adjacent in the array. Okay, so we have to find the maximum sum of the subsequence, that means sub array that can be created out of this array, and we have to take into consideration for the summation numbers in such that no two numbers should be consecutive in that array from this array. So let's understand this more clearly with this example. So in this example, it has been given the size of the array is 6, and this is that array which has been given with the element 5, 5, 10, 100, 10 and 5 again. So here it is saying the output as 110. If you take the indices 0, 3 and 5, then array of 0 plus array of 3 plus array of 5, that is 500 plus 5 is equal to 110. So here it is trying to say that if you are taking this number starting with index 0, 5, then we cannot take this 5 because this 5 is adjacent to the number which we have already taken into consideration. So the next number possible is 10 because this index 0 and index 2 are not adjacent. So if we take this 10, then 10 plus 5 it is 15, then we cannot take this 100. So because this 10 and this 100 will become adjacent to each other. So instead of taking this 10, it is better to take this 5 and this 100. That's why it has been taken here array of 0 and array of 3. Then after that, once if you have taken this 100, then we cannot take this 10 because of the same reason this will become adjacent to 100. So the only option left with us is to take this 5. So that only has been taken in this example, saying array of 0, 3 and 5, that is 5, 10 and 5, it is 110. So this is the example given, but how to approach to a solution? Let's understand the same example with the solution approach. Suppose we have taken all this exactly the same numbers here. So here the thing is that if you have only one number, that means if the size of the array is 1, so what will be the maximum sub array possible? That will be 5 only. If we have 2, if we have the size of array 2, then we have to take either of these two because we have only two options. So whatever is the maximum, we have to take that. So again with this option of 5 and 5, the maximum is again 5. So the solution, if the array size is 2 only, then we have to take a maximum of these two. The next option is that if we are taking this 10, if you are taking this 10, that means the size of array is 3, then the thing is that we cannot take this 1. So suppose if we consider that our question array here is limited to 5, 5, 10, the only option left is left with us to add 5 to this 10. So the only answer possible is 15 here. But once we go ahead, and when we go up to this 100, that is 100. So here what we can do, we have to, since if we are taking this one, then we cannot take this 10. So we have to take the maximum of, if suppose this is n, the n minus 2 and n minus 3. So here in this case it will be 105. We cannot take this 10. So we have to take either of these two number. So it will become 105. So now the thing is that if you are going up to this number 10, that means 10. So here the possible combinations are, we cannot take 100 for adding to this number, so the options left with us to take, if this is n again, then again we need to take n minus 2 and n minus 3, the maximum of these two. So if you add 10 to this 5, it is 15, and 10 to 10, then it is 20. So here the only option left with us is 20. Now if we are going up to the last one, then we see if this is 5, then the options left with us is to go for the maximum ones. We cannot take the answer which we have got till this one, because this will include the inclusion of this adjacent element 10. So the option again left with us is to go to the previous one, that is n minus 2 and n minus 3. So if you take both these options, then this number plus n minus 3, it is 15, that is 5 plus 10 is 15, and the other option is add n minus 2th index element to this number. So this is 5 plus 100, it will be 105. So this will become the 105, and this will be the largest array that we can get in through this one without taking into consideration the adjacent elements. So whatever the explanation that has been given here, so we are approaching to this one using this approach only. That means whatever is the current reference, we will keep on adding the numbers that will belong to n minus 2 and n minus 3 number, and we will be taking the maximum of that. N minus 1, this one we cannot take into consideration, that's just the previous number, because it will violate the adjacency, the constraint which is there in the question. So whatever we have discussed, let's try writing it in code form. I'll be using Java here to write solution for this. So whatever we had considered, if it is just one number, so the output will be the same. So the same only I'll be doing here. If size is 1, that means n is equal to 1, then we can directly return, here it is asking to return the integer, so we can directly return array of 0. If this is not the scenario, that means if the size is not 1, but if the size is 2, and if the size is 2, then what we can do here, we can return math dot max of array of 0 and array of 1. If we have only two elements, this 5 and 5, then we can return either of them since the element is same. But if any element is different, then we have to choose the maximum out of those two elements, and we have to return that only. So this becomes the solution if that array is limited to 2. For next of the things, what we can do, for if you're going up to this one 10th, that means till this one, so what we had an only option to add this one index 0 to index 2, because we cannot take this index 1 because adjacent to each other. So this 5 can be added only to this 10 can be added to this 5 only. So the same thing I'll write here as well, that array of 2, it will become array of 2 plus array of 0. So we have cleared up to now we have approached the solution up to array of 2. Now for rest of the thing, we can try running for loop, and we can keep checking the approach which we have discussed here. That means whatever is the number consideration, we have to check the summation of this number plus n minus 2 and n minus 3. Whatever will be the maximum out of those two, we will keep that into consideration. So for that, we need to start with int I is equal to 3, because we have already taken into consideration up to 2, array of 2. So we are starting with 3. Then it will go up to size of array. Then we can increment it by 1 each time. Then we can keep on adding array of I, that is the third position here. In this one, we can add array of I plus math dot max of array of I minus 2 and max of array of I minus 2 and array of I minus 3. We cannot take I minus 1 because again it will become adjacent to each other. So whatever is that current index in reference, for that we will do I minus 2. That means for 3 it is I minus 2, that means index 1, and for this one index 0. So if you are taking into this one, then to this we need to add either this or this, whatever is the maximum. Eventually it is happening here that both the numbers are same, so we are getting the same output. But if this number has been something different, then we can get different output. We have to take the maximum one out of that. That means whatever is the maximum one in that. So here we can proceed with this, saying this one, then we'll close this for loop is getting closed here. Now once this for loop is done, then we can return our solution saying return math dot max of array of n minus 1 array of n minus 2. That's it. So this last statement says that whatever combinations we are taking, it will always be the one of the last two, because for approaching to these last two options, we have already covered the previous scenarios. So the output will be the maximum of the last two indices summation. So with this in mind, we have pretty well done with the solution. So let's try compiling and running this. Okay, so we have got this solution here, this answer of 110, what was given in the example 1. So now let's try submitting our solution. Probably your code doesn't work correctly for multiple test cases. The first test case where it failed is 49476. Just a minute, let me look into this. I plus plus and I less than n, I plus plus, here to the end we are doing, and I plus plus is equal to max of area of n minus I minus 2 and I minus 3, then return math dot max of. Okay, here we need to return the maximum of last two elements. So here one mistake is there. Instead of I minus 2, I just given here I minus 1. So let's make it to 2. Try running it again. Okay, so let's try submitting this solution again. Hope you get everything correct this time. Yeah, so okay, so this was that error here. I have to take the maximum of the last two indices summation, the summation of the array, that means sub array, whatever we have calculated for last two elements, whatever is the maximum among those two, we have to take into consideration that one. So instead of n minus 2, by mistake I had written here n minus 1. So now we can see we have solved this question. And we have got all the test cases covered. Okay, so that's all in this video. Please like, comment and share the video, and please subscribe to the channel for more such upcoming videos. Thank you for watching.